Okay, y is equal to negative 3x cubed plus 9x. Determine the turning points and whether they are local maxima or local minima. First of all, piece of paper, don't tell me what to do. If you're going to insist on doing that, a simple please would be nice. That's better. Okay, so here we go. We're going to determine, first of all, where the turning points are. We've been over that before. You find the first derivative. You put 0 in for y because your gradient is 0 at the turning points. So we found the first derivative. Actually, pause the video and find the first derivative on your own. All right, now we're going to proceed. See, here's the first derivative. I made a little error here, but just ignore that tape. And we have the first derivative. And now we're going to substitute 0 in because at turning points, again, your gradient is 0. So we put 0 in for the first derivative. And now we're going to have a difference of squares. Okay, so I went ahead and factored out the -1 to make it easier to solve. So you're going to notice there's not a -1, but that sign changed. So I divided the whole equation by -1. 0 divided by -1, 0. That part's finished. Now we're going to proceed. And here we have our difference of squares, which is 3x plus 3, 3x minus 3. We solve for x and we get 1 and -1. Okay, and now we're going to solve for y. Now when we solve for y, we have to put it back into the original equation. So we're going to put each value back into here to find out where our turning points are. Remember, a point is a coordinate that's defined by 2 variables. All right, so here's our next step. And we went ahead and we found our turning points, and here they are. And it might be obvious what our local maximum and local minima are. Local maxima and local maximum and local minimum, where they are. It's that we're dealing with a cubic function. And as you know, like, they go like this. But I need to show you the process. That's the whole purpose of this video, of finding the local maxima and local minima, okay? Let's go ahead and proceed. So this is the step we're doing next. Situate my paper. And this is the rule. So just remember this rule, the second derivative. And the second derivative is the derivative of the first derivative. So we're going to take the derivative of y prime is equal to 9x squared plus 9. Easy, no problem. This part, I recommend just memorizing or learn it. Okay, so y prime. If it's greater than 0, it's a local minimum. If it's less than 0, it's a local maximum. Next, the second derivative, we found it. We put in the -1. Remember, we got 2 values for x. We got 1 and -1. I just started with the -1. And we find out that 18 is, we didn't find that out, we already knew that, is greater than 0. So that means -1, -6 is a local minimum. And I went ahead and put in 1 into the equation, into the second derivative. And as you know, -18 is less than 0. Therefore, that's a local max. And here we go, sure enough, 1,6 is the local max, -1,6 is the local minimum.